the key I used is wrong. So the decryption produces an unrecognizable output, which we know is wrong. So this is an important assumption, or last two are important assumptions for how we use encryption for confidentiality, but also later for authentication. It requires a bit of thought to get your head around that logic. I suggest you do that over the next 24 hours or so. Tomorrow we'll look at an example to summarize that and move on to the other aspects of encryption, where we get to authentication will be the next thing that we look at. Right, we'll look at that tomorrow. Let's stop there. So on symmetric key encryption, we introduce some notation and then said, for example, that we'll assume if we decrypt the ciphertext with the correct key, we'll get the original plaintext. That's the assumption about the algorithm, and that the decryptor will be able to recognize the plaintext is correct. And so the opposite, if you decrypt the ciphertext using the incorrect key, we will not get the original plaintext. And the decryptor will be able to recognize that that key is wrong because it's not it's random-looking plaintext, unrecognizable. We're going to go through these assumptions and some others and see how we use them to provide the feature of the services of confidentiality and authentication and integrity. The assumptions are spread through this handout. But if you scroll forward a few pages, you'll see that there's a page, or 2 pages that summarize all of the assumptions together. So you may want to refer to that. It's the same text, but just everything's combined together. And what we'll do today is look at how we use these assumptions to build up our cryptographic techniques for providing confidentiality, integrity, and authentication. So we may not use the slides much today, or draw some pictures and refer back to these assumptions. The first thing, a key security service is confidentiality. I send something to someone, an attacker intercepts that message, I don't want them to be able to read it. So we know we encrypt the message before we send it. We started to draw that yesterday, but I'll draw it slightly different. That is user A and user B are the normal business. A got some plaintext, a message it wants to send to B. I'll denote it with the subscript T here, meaning the plaintext that we think transmit to send. We don't actually send the plaintext though, we encrypt it. We obtain some ciphertext by encrypting, using some key, the plaintext. Where the plaintext, I'll denote as PT, is encrypted with a key, and we obtain ciphertext CT. CT is the ciphertext we're going to transmit to user B. What's the name of the key we're going to use here? What subscript am I going to write for this example? Think about the notation we introduced yesterday. What's the subscript for the key? This is a shared secret key, KAB. It's a key shared between user A and B. If user A wants to send a message to B, then they use the key shared between them and B. So I'll write this as subscript KAB. So that's what we do before we send, and we transmit a message to B. What do we send to B? Oh, we'll just summarize here, CT. Actually, right,